Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I be to Dr. Agmi, our group supervisor and our examiner for EIS project. So I hope that this video finds you well and you are in good health, especially during this unprecedented time. So my name is Asfa Adi bin Abdullah from Group 24, and in this video, me and my group mate will be presenting our EIS project entitled Catastrophic Rupture of Heat Exchanger at Tesoro Anacortes Refinery in 2010. So here are the outline of our presentation today. So first of all, we are going to look at the introduction part, where we get to know on the overview of the incident by Yiling. Next, we will go deeper on this incident as Shame will be presenting about the chronology and the impact of the incident that occurred. After that, me and Jayang will clarify on both technical and ethical reasoning as the main cause of the incident occurred, followed by Zarif, in which he will be covering the lesson learned from the finding of the analysis and accident happened. Lastly, Yiling will wrap up the session by concluding the finding of our project. Without further ado, I would like to invite Yiling to present on the introduction part. Thank you.
Thank you, Adi. I'm Yiling going to brief you about this chapter. Tesoro Corporation started as a petroleum exploration in 1968, while this catastrophic rupture of heat exchanger occurred at the refinery in Anacortes, Washington on 2nd April 2010. The rupture of heat exchanger occurred at the naphtha hydrotreater unit. The main cause was found to be high temperature hydrogen attack. While this highly flammable hydrogen and naphtha with high temperature were released from the rupture heat exchanger and ignite, the sudden release triggered a massive explosion, an intense fire that lasts for more than 3 hours with a temperature of 500 degrees Fahrenheit. This incident killed 7 Tesoro employees, the largest loss of life at a U.S. refinery compared to the BP accident in 2005. In this figure, NHT unit consists 2 parallel groups of 3 heat exchangers, ABC and DEF. The objective is to preheat process fluid before entering the reactor. Later on, Shami will describe in more details for the chronology part. Thank you.
Thank you, Yiling, for the introduction. My name is Wan Muhammad Shameh, and now we are going to discuss on the chronology of the incident as well as the fatalities and damages Tesoro and Anacortes refinery suffered. During the pre-incident operation, the ABC and DEF heat exchangers were running during normal operation. These heat exchangers were experienced fouling during operation because of the original Shell Oil Company design and the process condition as illustrated. Hence, periodic cleaning needed to be done to maintain the process temperatures requirements of the heat exchanger. However, the activity of placing back the heat exchangers into service, startup, shutdown and cleaning activities were considered to be dangerous non-routine operations to avoid a total shutdown of the NHT unit because of a long history of leaks and occasional fires. In addition, only one bank of the heat exchangers was taken offline and the rest of the unit remained operated. The startup of the ABC heat exchanger bank was initiated on the evening of 1st April 2010, and the startup procedure was considered to be tough to be done by only a single outside operator, as it required manipulation of several block valves, isolation, which took a huge amount of manual effort to be opened. 6 additional Tesoro employees consisted of 5 operators and 1 supervisor joined the outside operator at 10:30 p.m. for startup of the heat exchanger. The roles of these 6 additional personnel had not been specified during the startup procedure. So during the startup, 2 leaks from the heat exchanger were reported, and the leaks did not stop the operation as it was considered to be frequent and had become a normal part of the startup. So at 12:30 am on the 2nd April of 2010, E heat exchanger on the adjacent in-service bank was catastrophically ruptured, while the 7 operators were still performing the startup operation for ABC heat exchanger bank. Based on the figure below, we can see that the shell of the heat exchanger at weld seems to expel a large volume of very hot hydrogen and naphtha. So the naphtha and hydrogen released from the E heat exchanger into the atmosphere were likely auto-ignited, creating a large fireball. The impacts of the rupture were felt by the inside operator in the NHT control room, which located 350 feet away. All 7 outside operators were severely burned, and all of them lost their life within 22 days of the incident. The Tesoro Refinery had been fined in 2009 for 17 serious safety violations. Those fines were later reduced to 3 violations and cost about $12,250 settlement. The Washington Department of Labor and Industry also accused Tesoro of willfully breaking the law 39 times. And in October 2010, the agency hit Tesoro with the biggest workplace safety fine in the state history, which is $2.39 million. Now, we will look into the technical and ethical issues for the failure to occur.
Thank you, Shame. My name is Asfa Adib bin Abdullah, and I will be presenting on the technical reason of failure for the rupture of Tesoro Refinery heat exchanger. The first technical reason is the presence of untreated post-weld region in the heat exchanger. A treated post-weld is necessary to ensure that the material strength is retained after welding. However, in Tesoro Refinery, the heat exchanger does not undergo this treatment. The figure in the slide shows the position of the untreated post-weld in the E heat exchanger in Tesoro Refinery. Due to the untreated post-weld region, this will cause a higher stress area and lower strength region that made hydrogen attack prone to happen. This caused more hydrogen attack with bigger effect on the carbon steel. This technical reasoning was supported by CSP finding as the rupture occurred across the heat exchanger was across the untreated post-weld area. Okay, the next technical reason is Nelson curve and accuracies. CSP has conducted a computer reconstruction process to obtain the operating condition of the ruptured heat exchanger and comparing it to the Nelson curve. Nelson curve is recommended by American Petroleum Institute to ensure that the heat exchanger is operated below the Nelson curve, which is the safe operating condition, to avoid condition favoring hydrogen attack. Based on the data gathered, the heat exchanger was operated below the Nelson curve, which is a safe region, as you can observe in the diagram shown in the slide. However, hydrogen attack still occurred. This proves that the Nelson curve is not reliable to predict hydrogen attack as practiced by Tesoro Refinery. And thus, it needs different approach to prevent hydrogen attack instead of solely depending on Nelson curve, as its reliability can be questioned this day. Next, I would like to pass the floor to Jayang to present on the ethical reasoning for failure.
Hi, my name is Wang Jayang. I'll explain the ethical issue for the failure. First and foremost, the heat exchanger has a history of leaking. The earliest documentation of the leak is from 1997, which is more than a decade ago, where the plant is still owned by Shell Oil. The leaks were very hazardous, as there were hot naphtha inside the heat exchanger, which is operating at near auto ignition point. Throughout the years, there have been several attempts to stop the leaks. However, no good solution has been presented, so the leaks has been accepted and become a normalized condition in this plant, which will eventually lead to this incident. The organization failed to provide a good solution to this incident. Some even could say the normalization of this problem is the main cause of the incident. The other ethical issue for the failure is the organization did not effectively control the hazardous condition. During the incident, 6 personnel are present inside of the heat exchanger. They are inside the heat exchanger to assist with the steam nest in anticipation of the leak. This is because steam nest can create steam suppression, which can mitigate the leak of the heat exchanger. As you can see in the picture, the 2 yellow circles are the steam nests used to mitigate the leaks. The organization failed to protect them by exposing them to the dangerous condition. The organization has a responsibility to provide a safe and healthy environment for the engineers to operate the heat exchanger. One could say the failure to do so is the main reason of the incident.
Hi, Assalamualaikum. My name is Muhammad Zarif bin Abdul Malik. In this video, I will present on the mitigation and recommendation. The first mitigation is to moderate the temperature inside the system. According to process data, the outlet temperature increased by about 75 degrees Fahrenheit in 3 minutes before the rupture. So by applying the inherently safer design strategy, moderation of the temperature inside the system can be done to minimize the risk of getting the HTHA. The second mitigation is to simplify the heat exchanger design from 2 banks to 1 bank. So there are a total of 6 exchangers involved in the incident, which was arranged in 2 banks with 3 exchangers on each bank. Prior to the incident, 1 bank was taken offline for maintenance purposes. However, the other bank was still operating. It is recommended that Tesoro Refinery to redesign the heat exchanger units into a single bank, as the entire unit must be shut down in order to eliminate the hazards of online switching and creating a much safer approach for maintenance. The third mitigation is to substitute the equipment material of construction. The material of construction must be upgraded to a more HTHA resistant to eliminate the potential for the incident to happen again in the future. A higher chromium steel is more suitable for the material of construction of the heat exchangers, as chromium can avoid uniform high temperature of the NHT unit. Finally, the substitution of non-post weld to a post-weld heat-treated exchanger is recommended. This is so that a safer design can be applied through the post-weld heat treatment for the heat exchanger. The process of post-weld heat treatment consists of controlled heating and cooling steps applied to the welded structure, which readjusts to its original prefabrication state. Thus, the carbon in the steel used as the material of construction of the heat exchanger becomes less reactive, inhibiting the reaction with hydrogen to form methane. That is all from me. Thank you.
Thank you, Zari, for the recommendation. I would like to conclude the presentation today. In this incident, operator or the employee would prompt to normalize the occurrence of hazardous condition as one of the ethical analyses mentioned by Jaya. Hence, the CSB recommend the government to require refineries to conduct more comprehensive hazard analysis and damage mechanism reviews. Besides, promote wider usage of safer design. And the CSB also determines such regulatory changes will help prevent future incidents like the tragedy at Tesoro, where many opportunities to identify and reduce hazard were overlooked. 7 lives were lost at Tesoro. It should not have happened. Companies, workers, and community would all benefit from a more rigorous regulatory system that is focused on continuously lowering risk. Thank you.